Hey everyone, welcome back. So you decide you are building your AI application on Azure at an enterprise scale. You know that you need Foundry, you probably need APIM in front of it, you want private networking, observability, the whole thing. And you also want Terraform to deploy all this. So where do you start? Microsoft has published an official Terraform reference implementation that already makes all those decisions for you. It's called the Azure AI Landing Zone. This is a real production blueprint that deploys networking, AI Foundry, APIM, observability, private endpoints, and even the jumbos that you will use. It's built on Azure Verified Modules or AVMs, which we will get into it. Today I'm gonna walk through to the whole thing, what it actually deploys, how the Terraform module is structured, what decision it makes for you, and where you still need to make your own calls. By the end of this video, you'll know exactly whether this is the right starting point for your workload, and if you do so, you will know what you are getting into. So let's go. First, some context on what this thing actually is. In the Azure world, a landing zone means a pre-configured environment that follows the cloud adoption framework and the well-architecture framework guidance. The Azure AI Landing Zone is exactly that, but it is scoped to AI workloads that are running on Azure PaaS services. Specifically, it is running on Microsoft Foundry, APIM, AI Search, and the supporting services around it. It is an application landing zone. That means that it is not setting a management group or policies at the tenant level. This is one level below that. It provisions the actual infrastructure your AI application runs on. There are two deployment modes for this architecture. The first one is with a platform landing zone, which is the recommended enterprise path. It assumes you already have a hub VNet with a firewall deployed somewhere. And the AI landing zone, what it's gonna do is deploy the spoke VNet and peers to your hub. It also routes all the outbound traffic through your existing firewall, and the DNS resolution flows through your central private DNS zone. It basically plugs into your existing enterprise network topology. With our platform landing zone, it's the standalone mode. It creates its own VNet, and optionally, it deploys its own Azure firewall, manages its own DNS, and this is the right starting point if you don't have already a hub and a spoke topology, or if you are deploying this in isolation for a proof of concept that needs to be production grade. One more structural thing worth mentioning is that this AI landing zone is actually two composable units. The Foundry landing zone, which covers the AI computing data services, and the APIM landing zone, covering the gateway layer. Both here are shown as separate reference architectures and can be deployed independently or together depending on your use case. Later, we will see that in the Terraform module, APIM is included as part of this Foundry landing zone deployment. But if you want the APIM gateway as a standalone landing zone separate from Foundry, you can use this one, but the implementation is in Bicep. Let me walk you through every layer what this actually deploys, and we will be using the AI landing zone with platform landing zone, which means that we will connect to our existing hub. The networking foundation, it's a VNet with a set of pre-configured subnet, each scoped to a specific workload roles. For example, we have the API management subnet, the container app environment subnet, and so on. And we have NSG per each subnet. In this case, we have also route tables configured based on which mode we are. If we are using, for example, the platform landing zone, like in this case, the egress routes of the table point to the firewall IP. And if we are using the standalone, the app gateway subnets need direct access to the internet. And also Azure Bastion is deployed by default for secure access to the private environment. This section is the core AI layer. In this part, you will get an AI Foundry hub with one or more Foundry projects under it. The model deployments are fully configurable. You specify which models, the scale type, what capacity, and the hub that we define here wires up to a set of dependent services: AI Search, Cosmos DB, Keyboard, Storage Account, or Azure App Configuration. And for each of these dependent services, we have two options: bring an existing resource ID, or let the module create a new one with defaults. We also have private endpoints deployed for every one of these services by default, so nothing is publicly accessible out of the box. The default model that we deployed in the example configuration is GPT-4o, but as I mentioned, they are fully configurable. You can specify the model name, the format version, the scale type, Just make sure that you have the quota in your target region before you apply. API management is deployed as the AI gateway in front of Foundry. APIM sits between your clients and your model deployments, handling authentication, rate limiting, routing, and even observability. And there is something important that I want to mention here before you go into the module and deploy this into your infrastructure. The default SKU for APIM in this module is Premium, with 3 capacity units. With these specifications, it costs roughly $2,000 to $3,000 a month per region. So that's intentionally for an enterprise production, but it's a decision that you need to be aware of, not discover after a Terraform apply. Application Gateway with WAF version 2 sits at the edge, handling ingress, and it is set to auto-scale between 2 and 10 units by default. Behind this application gateway, a container apps environment hosts your GenAI application code. This is where your application layer lives, whatever it's calling Foundry and handling the business logic. Here we also have a container registry used for storing and serving the custom container images that your container apps pull from. Because everything is private, a JumboOps and Azure Bastion are also deployed for secure management access, and a separate VLBN is also provisioning for running Terraform operations or running your pipelines to deploy to Azure resources. For observability, there is log analytics and application insights deployed, and every resource that supports diagnostic settings has then enabled by default and pointed at the workspace that we defined. Now let's take a look at how this is actually built in Terraform. The implementation lives in a separate repository from the main AI Landing Zone repo. This is an AVM pattern module, and you can identify that by the name AVM PTN. Azure Verified Module has 2 tiers: the resource modules that wrap individual Azure resources, and the pattern module that compose multiple resource modules into a solution. This one is the latter one, and it calls AVM resources modules underneath. It never calls Azure RM resources directly. You will need 5 providers: AZ API 2.4, Azure RM 4.x, ModTN, Random, and Time. AZ API is required, it's not optional, because some of the resources in this stack aren't fully covered by Azure RM yet. The module follows a consistent naming convention that makes it very readable, and every domain has its own pair of files, locals.tf and main.tf. So we will have main APIM, main compute, main Foundry, and so on, and we will have the corresponding locals here above. Each of these locals files construct the configuration object that gets passed into the corresponding AVM module code. 3 variables that are required: location, resource group name, and VNet definition. Everything else is optional with sensible defaults. VNet definition is where the platform landing zone behavior is controlled. If you pass this one, the module skips VNet creation and wires into your existing network instead. If you pass VNet peering configuration, it sets up the spoke and hub peering for you, and if you do this one, it does the virtual WAN connection variant instead. This variable is the most complex one in the module. It's called AI Foundry definition, and it's a single large object that controls everything about the Foundry layer: the hub configuration, the model deployments, Foundry projects, and all 4 dependent resources definition that we talked before. Each dependent resource accepts either existing resource ID or a set of creation parameters. There is this boolean called flag platform landing zone that switches the routing behavior. When it is true, routes tables user virtual appliance like a firewall as the next hop, and when it is set to false, certain subnets like the app gateway subnet get internet as the next hop instead. And this exception exists because application gateway version 2 simply doesn't support routing through a virtual appliance. It is worth to mention the difference between AVM modules versus writing Azure RM resource directly. AVM resources modules are Microsoft maintained, tested against strict specifications, and version independently. They enforce consistent patterns for things like diagnostic settings, ARBAT assignments, private endpoints, and tags. And when Microsoft updates the module, you update the version pin and get the improvement. The trade-off is opacity. When something goes wrong, you are one level of abstraction away from the raw API. And also the variable schemas for some of those modules, like the endpoint or AI Foundry, are complex. Before you run a Terraform applied against this module, there are some things that I would like that you check. The official cost guide puts the full deployment without APIM at roughly 3.1k USD per month. And when you enable APIM, you get about $6,000 per month. That is before a single token is processed. This isn't a criticism. I mean, this is intentional for enterprise grade infrastructure, but it should be something that you have in your mind, not a surprise on the bill. You can make optimizations for def and test, like disabling firewall, bastion, and downgrade the SKUs, but be aware of this. So here's the bottom line. The Azure AI Landing Zone Terraform module implementation is production grade. It's not a quick start. It is a reference built on AVM that handles networking, security, observability, and the AI infrastructure together. Microsoft is developing, and it directly aligns with the AI scenario guidance defined in the cloud adoption framework. I think this is the right starting point if you are making the initial steps to an enterprise AI workload and want a baseline to extend from, rather than assembling everything from individual AVM modules. And also, it's probably too much if you are building a focused internal tool or a proof of concept that doesn't need private network or observability. If you find this useful, subscribe for more content like this, drop a comment if you are using this module, or if you have questions about it. Bye bye.